So now, hopefully on my screen here, you can see the periodic table. So we're going to use the periodic table to find key information about different elements, which you might be asked in exams. And this can come up in loads of different ways in the exam. So it might not say, tell me about hydrogen. It might be a different question, but actually you need to look at your periodic table to find the information about hydrogen to then answer the question. And it works to your advantage because you always get a copy of the periodic table at the front page. That's another top tip. So elements are now arranged in order of their atomic number. So rather than their atomic weight, their atomic number and the number of electrons in their outer shell. So atomic number is the number of protons an element has. So if you remember that diagram I just drew, in the middle you've got the nucleus, you've got protons and neutrons. Atomic number is the number of protons that are in that nucleus, and it is the same as the number of electrons which are in the outer shells. So let's go back. Well, let's read this statement and then we'll refer to the periodic table to understand what I'm on about. So all elements in group 1 have 1 electron in their outer shell. All elements in group 7 have 7 electrons in their outer shell. This means that all elements in each group have similar reactivities and therefore similar properties. So if we go back, this is group 1. All of these elements have 1 electron in their outer shell. So as we go down, the elements are increasing in their atomic number, which means the number of electron shells in total is getting bigger. So this row has 1 outer shell of electrons, this one 2, this one 3, and so on. And then the group, so we've got group 1, group 2, 3 is here, 4, 5, 6, 7, 8. That tells us the number of electrons in the outermost shell of that element. So for example, over here, we've got group 5. We can see nitrogen here. We can immediately see, okay, that has 2 shells of electrons and it has 5 in its outer shell. So how I'm getting that information? It's in the second row down. That means it's got 2 shells. And I'm looking at which group it is. That is a tiny number 5, or we can count across. So 1, 2, 3, 4, 5. That gives us a lot of useful information about nitrogen. And it also means that we know all these elements in group 5 down here, they all have similar properties because they all have 5 electrons in their outermost shell. Hope that's all making sense. So that's a little bit of maths for you, but those 2 facts I've given you about the outer shells and the number of shells, you can then tell me information about all the elements in the periodic table. Really nice exam questions if those come up. So name the first 10 elements of the periodic table. Put this in as a little brain break, really. I just learnt them off as a little thing. I just used to recite it. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I've written that a little bit wrong there. Sorry about that. But obviously, as I said before, you get the periodic table in your exam paper. So you can just refer back to that. You might get a question about that, just getting you to check if you can use the periodic table and you can identify different elements. Again, quite a nice, easy question. So this learning objective is pretty similar to the one we just covered, but we're going to take it a little bit further now. So we're going to use the periodic table to find the electronic structure of an element. So a little bit of recap from what I've already discussed. So every atom of an element has a nucleus in the middle. Draw this out again. So we've got a nucleus here, and inside the nucleus are protons and neutrons. And then we've got our electron shells. And if you remember, the number of shells that we've got is determined by which period or which row of the periodic table an element is found in. So each shell can hold a different maximum number of electrons. So the shell closest to the nucleus, it can hold 2 electrons. When we draw electrons, we can draw them either as crosses or as dots. You would keep it the same. So this would be wrong. I'm just showing you that there's 2 different options, but you would need to do it either both dots or both crosses. Either is fine, it doesn't matter. The second shell can hold up to 8. So I won't draw them all, but we've got 1, 2, 3, 4, and so on. 5, 6 there, 7, 8. And as you can see, the third shell contains 8, and so on and so forth. Now, when electrons are occupying the shells in an atom, they always fill the shell closest to the nucleus first. So say we've got 3 electrons. We're always going to put 2 in our shell innermost to the nucleus first. So we're going to put 1, 2, and then we'd have 1 in the next shell. If we had 5, we would have 1, 2 in the first shell. Then we'd go to the second shell and we'd have number 3, 4, and 5. So we would have 2 electrons in the first shell and 3 in the second shell, and so on. Got an example here. So I'm going to do this one, and then I'm going to ask James to pop on for our second question, and he's going to give it a go. So if you're watching live and you want to pause and have a go, that's absolutely fine. If not, I'm just going to go for it. So if an element contained 15 electrons, how many would be in each shell? So I'm going to draw this out. So I've got the nucleus here, and I've got the 3 shells. So 15. So we know that there's 2 in the first shell. The next shell we know can take up to 8. We can fit 8 on there. So 1, 2, 3, 4, 5, 6, 7, 8. Total now, we've managed to put 10 into our atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 15, so we can still fit 5 more in our third shell. 1, 2, 3, 4, 5. Please excuse the drawing. It's very hard to do on a, I've not got my mouse with me, but never mind. And how you would write that structure, if it asks you what is the electronic structure of this particular atom or element, you would write 2, 8, 5 with commas in between. So first shell, second shell, third shell.